Okay, so now in this video, I want to talk in a little bit more detail about some of the conventions that R uses. This video is based upon things that really confused me back when I first started using R. It wasn't intuitive to me. Maybe it's very intuitive to you, but to me this is what caused me a lot of trouble, and this is what I also see students having trouble with, and so I wanted to address some of those in this particular presentation. And so I just want to talk about some basic conventions, and then I'm going to talk a little bit about data classes, and then finally importing data. These are all things that are really important to really understanding what you're doing in R. I want to start with some general rules that I have. Rule number one: there's more than one way to skin a catfish. All right, there are always several ways to do the same thing in R. And so you might ask someone, how do I do this in R? You might get several answers. Or, I teach you how to do something in R, and then later on, someone else does the same thing, but they do it a different way. That's okay, all right? Now, some ways are better than others, and we always want to improve, but there's that one saying, if it's stupid but it works, it's not stupid. You always want to do things the right way, but realize there's not necessarily a right way to do things in R all the time. Just be comfortable with that, okay? That's how open source software is as everybody kind of has their argument, well, I like to do it this way, well, I like to do it this way. Those are not necessarily bad. Find something that you know works and stick with it. Rule number two: if you can imagine it, you can do it in R. Okay, the trick is to figure out how to make R do it. So if you can picture a graph in your head, you can make R make that graph. You just got to figure out how to do it, all right? If you want to combine data in some way, R can do it. You just got to figure out how to make R do it. Chances are someone else has already had that idea. Somebody else had at least a similar idea, and so Google around, find their answer, and figure out how to adapt it to your situation. But if you can picture it, you can do it. Rule number three: it is worth all this trouble. After all these first couple of videos and working, you might say, God, this seems like a pain. Why do I want to mess with this? It's worth it. Okay, if you are, want to be on the cutting edge, 21st century, if you're going to be doing things that involve data, which is pretty much most jobs, you're going to be manipulating data somehow, R is worth it. And once you learn it, then you can really make it do a lot of things. Future employers are going to be looking for these skills. And so this is, again, one of the reasons why you come to the university. Okay, so many of you might not be programmers. I'm not a programmer, right? I'm a biologist. I like programming, and I've been into it forever. Not everybody gets as excited about it as I do. And so the thing is you don't have to be a programmer. You don't have to get super deep into the code. You do have to understand just some basic things. And if you have a basic understanding of what the software is doing, it really helps you use it. It really helps, and it really helps you when you have errors, or and you're trying to figure out what the problem is. It really helps you be creative. And so in general, there's a basic structure to most of R. Most of the time you issue commands with the format function, and then inside parentheses you have arguments. Okay, one of the tricks to understanding R and understanding the language is to understand the terms that people use. That way when you ask a question, you can ask the question properly, and you guys know what you're talking about. And so functions are like commands, and I'll use those two interchangeably because I'm an old fart and that's just how I think. But it's basically telling R to do something, commanding it to do something. That's a function. And then often that function needs some arguments or needs some details, and those often come in the parentheses. Now, it's not always like this, but if you think about things, if you recognize this structure, then you can see that when you look at other people's code, and it makes a lot more sense. And so like you can tell R to do something, plot these data, but you got to tell it, well, what data? And that would be an argument, right? So plot is the function, is the command, and the data name is the argument, right? And so if you look at my simple example here, this is just to make a simple map. And I've got a couple of commands. I've got a couple of functions. I've got ggplot and I've got geom sf. Each of those is a function or a command, right, that tells R to do something. Each of them has these parentheses that have room for some arguments. So ggplot tells R, hey, plot something, all right? That's just a basic command. We're going to plot something. And you notice it's got those parentheses, and you might go, why do I have these parentheses and there's nothing in there? Okay, well, you know, there could be something in there. In this example, I don't need any arguments, and I don't need to put anything in there, but I still need those parentheses, okay? But in other examples, I might want to stick something in there. I might need some arguments to send to the ggplot function, and so they will go inside those brackets, inside those parentheses. And so again, maybe this doesn't freak you out, but when I first started learning, and it just drove me crazy. I'm like, why sometimes there's stuff in the parentheses and sometimes not? Why do I even need these if there's nothing in them? Well, you just do. All right. Now, if you look at that second function, second function tells R what kind of plot. The first one said, hey, we're going to plot something. This geom sf says, well, this is what we're going to plot, or this is the type of plot. And in this particular instance, it's going to be a map, okay? And so you may or may not ever use that function. But you see, there is something inside the parentheses for this function. There are some arguments. You need to tell R what you're going to map, where the data are. And so in this simple example, data equals map.dat. And so that tells R, hey, there's data in a data frame named mat.dat. So somewhere in my memory, I have a set of data, and I've named them mat.dat. And so now R needs to take those data and make a map of them. That's what all these commands are telling R to do. Okay. The next idea that, again, gave me trouble until I sort of understood it is this idea of data classes or classes. And again, if you're a computer person, if you're a programmer, this is second nature to you. But if you're not, you might not realize the importance. But I have come to appreciate the importance of understanding classes in R. It can solve a lot of problems. And so everything has a class, or you can think of it as a type in R, and that controls what that thing can and cannot do. This is not unique to R. This is all programming. You'll see this in a lot of things. You do this in a lot of your, there are a lot of places where this actually, you're doing this subconsciously and you don't know it. Right? Like, you know, a date class is a common class, right? And you know what a date is, right? Would you ever multiply dates? Would you say, I want to take Monday the 4th times Wednesday the 17th? That's nonsensical, right? You don't do that. That's because intuitively you understand dates don't do that, right? You know? And so that's kind of what we're doing with classes here. Like everything that you work with has a particular class, and it tells you what it can and cannot do. And so something that you should get in the habit of doing is using the class function. So here's a function, here's a command you give R, and it says class. And you can ask R, hey, what's the class of this? What's the class of that? And that will help you understand what that thing can do and cannot do. And that helps you find errors a lot of times and helps you understand what your program is doing. So you remember earlier, I showed you a function called ggplot. Well, what if I didn't remember what ggplot was? I'm like, what is this thing? Well, the first thing I could do is use the class function. What's the class of ggplot? That'll tell me what I'm doing. And so I could just type class, and then in the parentheses, ggplot, right? So class is the function. I'm telling R to do something, and the arguments in the parentheses, well, what are you going to tell me the class of? Well, this ggplot. And you see the result that it gives you here is function. And so, you know, I don't know what ggplot is. Well, I know it's a class function. Oh, okay. So now I know that ggplot is a command that I give R. It's not a data set. It's not a date. It doesn't hold data. It's a function. So it's something that R does. And so just by using this class function, you can figure out what different things are. And so a lot of times things don't work in R because you've got the wrong class. You're trying to do something that thing is not allowed to do. And so, you know, if you get in the habit of just always paying attention to what class things are or checking the class of things, and it's real easy to do, that can help you avoid problems or solve problems or at least explain problems. So here are some common classes that we're going to run into. We just saw function. And again, a function, that's a command that tells R to do something. DataFrame is a class. Some things are data frames. Data frames will work with a lot. Data frame is something that has got columns and rows. Think spreadsheet, right? And so a lot of times we're going to import our data into a data frame because our data is in a spreadsheet and a data frame is just like a spreadsheet. So those two things are very similar. The date class, I kind of mentioned that. You know, dates are special, right? Sometimes they look like numbers, but they're, you know, they've got a hyphen in them. So they're, you know, or they're a mix of numbers and letters. It looks just like, you know, Monday the 4th could just be a bunch of letters, but it really has different meaning. So dates are special, and so they have a date class. And so if something is the date class, it's not treated as just text and it's not treated as numbers. It's treated special, you know, in a special way. The character class, that's just for like text, right? And so that's like a label. And so this is where this could be important, right? And so if you had something that was the character class and it had 1, 2, 3, 4 in it, you might look at that and go, oh, that's a number. No. R looks at it and goes, oh, that's not a number, it's just a bunch of characters, right? And so then if you try to like add something and it was a character class, R would go, what are you trying to do? You know, you can't add words together. And so that's one way that knowing the class could bail you out. Integer is what it sounds like. It just can hold integers, you know, numbers that have no decimal or have no fraction. Numeric would be any number, right? Whether it's got a fraction or not, a decimal or not, numeric class holds numbers. And so you could like multiply two things that were the numeric class, but you couldn't multiply a numeric class times a character class. It doesn't make any sense, right? You can't multiply a number times a word. And so, again, if you try to store something in the wrong class, you get an error. And so if you had something that was defined as a numeric class and you tried to store Murray State in there, you'd get an error. And it's because Murray State's not a number, and so it can't go in a numeric class. Okay, last thing I want to talk about is importing data. This is usually your first step, and it's an important step, and so I want to go into it in a little bit more detail. Let's just have a pretend example here. Let's say I've got a data set and it's a bunch of fish that I measured, and I measured their length and I measured their weight. And I want to look at the relationship between length and weight, right? And so chances are I'm going to write those numbers down in the field and then I'm going to type them into a spreadsheet, right? Now I need to get that spreadsheet into R. That's a very typical workflow. And so I've got the length in one column, and that's in millimeters, and I've got the weight in grams in a different column, and I've got those columns labeled. Now, I do a lot of this in Excel, but I don't want to use an Excel spreadsheet. I can save it as an Excel spreadsheet, but I can import those into R, but I've always had trouble with them. It's so much easier to save that file as a CSV file. I mentioned these earlier. This is a comma separated values, right? It's a very simple text file. It's not a regular Excel file. It doesn't have a lot of formatting and things. And so that's why it's a very commonly used, and it's kind of a foolproof system, and that's why we like to use those in R. There's no extraneous formatting. If you open a CSV file in a text editor, it looks like this, right? The values are separated by a comma. Excel is smart enough to recognize this and will put things in different columns, but they don't naturally come in different columns. At any rate, we're going to be working with CSVs a lot. Excuse me. Now, if I want to import this file, this CSV file, a lot of times the first thing I'll do is set the working directory. And this is something that's easy to do in RStudio. And here is the code that will do that. And I'll show you some real world examples later, and we'll do this in RStudio. But first off, you see I use a hashtag to make comments. And so this is in my R script. You know, I'm just reminding myself, hey, I'm just setting the working directory here. The working directory is just the folder where your data are stored. And so if you set the working directory, then everything gets saved there, and it just makes your life a lot easier. And you can see it's a function, set WD, that's a function, and then it's got parentheses for your arguments. So I'm telling R, hey, set the working directory. Okay, what do I set it to? Well, here's in the parentheses is what I want you to set it to. Of course, your name will be different, but you get the idea. Okay, so then I want to import those data. And when you import the data, it's going to go into a data frame. That's just kind of, you know, think of spreadsheets and data frames as being very similar. And I want to give that data frame a name. And when I give it a name, then I can refer to it. And so any command, any function that I need to do on that data frame, I can just give it that name, right? And so like it's, you know, when you save it, you gave it a file name. And so this is just the same thing. It's like a file name, only it's in the R program. And so I'm going to name this particular one fish.dat. Again, you can name things just about any way you want. You can make them really long. If you make them really long, then that makes it harder to type, so you try to keep them short. You can mix numbers and letters, just don't start with a number, all right? Don't put spaces in there. And you know, you can use an underscore for a space a lot of times. And again, you know, people who are into programming, they have conventions for how they name things. I don't know what any of those are. What'll happen is you'll do what I do, is that you'll just develop a style and you'll just kind of do things your way. That's fine. And so here again is what that code would look like in your script, okay? And so I've got the hashtag for the comments, and basically what I'm saying here is I'm going to create a new data frame. I'm going to name it fish.dat. I'm going to set that equal to something that I'm going to read in from a CSV. Remember that lower less than plus a minus is the same thing as equal. Read CSV is a function. It's a command. It tells R, hey, go and read in a CSV file. Well, what file am I going to read in? That's the argument in the parentheses. And so here's the name of the file that I want you to read in. You'll notice that I've got a dot at the start of that. That dot is shorthand for the working directory. And so instead of, you know, if I put the full name in, it's the working directory plus the file name. It's this huge name, and it makes the code very, very hard to read and very hard to type. And so these are little things that you'll pick up as we practice it, all right? So again, I'm going to read in a CSV. Here's the name of the CSV. Store that in a data frame named fish.dat. And so again, we always want to think about classes. We just created something called fish.dat. What's its class? Well, let's just use the class function and find that out. And so I type class and then fish.dat. So what is the class of this thing called fish.dat? It's a data frame. Cool. Well, that should be. That's what I expected it to be. But the thing is if you forget, or if you got a program from somebody else and you're like, I don't know what fish.dat, what is that? you can use this class function and figure out what that is. Oh, that's a data frame. It's like a spreadsheet. It's not a function. It's not a command. It's not, it's something that that contains data. And so again, once I import those data into this data frame, then I can look at it in RStudio. And this is what it looks like in RStudio. And it looks just like our spreadsheet. And so that just kind of underscores that these are very similar things. And so in the data frame, I've got columns and rows. Now, again, you have to get comfortable with the language that people use in this software. And so they talk a lot about vectors. And so sometimes people are talking about data frame, they'll talk about columns, but they also sometimes call those vectors. And so that's just something you want to get comfortable with, and don't get confused when you hear that word vector. But not only is the thing named fish.dat, that has a class. It's the data frame. But within that data frame, we've got these vectors, and those vectors also have a class. And so I can find out what the class of those vectors is too. And usually, I didn't have to set that. I didn't have to tell R what the class is. R can usually look at the data and guess what class it should be, and it gets it right about 99% of the time. But again, this is somewhere where you might have an error, where it guesses at the class and gets it wrong, and then later on in your analysis you have a problem. So we can use the same class function to see what is the class of those two columns that we just imported into the data frame. And you see the first one, we have class of length in millimeters. And the second one, we're asking what's the class of the weight in grams. But you see that both of those also are preceded by fish.dat with a $sign. And that's something that, again, you'll see and you'll be like, what in the world does that mean? That's how you're being very specific, and you're telling R specifically where to find this vector. The vector named length millimeters is inside the data frame named fish.dat. So we have to be very specific. You see that for both of these, they're considered the integer class. And so in those columns, when they were imported, they were just whole numbers. There were no decimal points. And so since they were all integers, R stored them as the integer class. And that may or may not be important later on, but it's important to know that. Now again, getting back to that $sign notation, as I call it, there's many ways to reference a vector, or many ways to reference a column in a data frame, and many ways to reference the row. I'm not going to cover all of those, but this is one way that I use a lot because it's very specific. It makes the code a little bulkier, but you always know what you're talking about. So many times those vectors are inside a data frame, and you got to tell R exactly where to find it. All right. And so I wanted to find the class of that vector named length, right? But if I just used just that name length, R wouldn't know what I'm talking about. So in this example, I said, hey, tell me the class of length. I want to know, is it an integer? Is it numeric? What is it? And R says, I don't know what you're talking about. Here's an error, it's not found. What do you mean it's not found? I just loaded it in. Yeah, you weren't specific enough, okay? And so if I change that statement and I say fish.dat $sign length in millimeters. Now that says, oh, this is a column, or this is a vector inside a data frame named fish.dat. And so now R knows where to look for that vector, and then it can tell me, oh, that's an integer, right? And so this comes up with a lot of functions. You've got to be very specific where those data are being held. Okay, so there's a lot of things we could talk about, but again, I was trying to hit those things that caused me confusion when I was first learning R. Everything in R has specific syntax, And a lot of that syntax is the same, or it's very similar across functions. And so if you learn some of these basic ideas, that will really help you understand your R code. Again, R has many ways to do the same thing. And so just because you and your friend do something differently, one is not necessarily better than the other. Sometimes one way is better than another, but just don't be surprised if somebody has a different way of doing something. I have my way of doing it. My way works, so that's what I'm going to teach you. And the final idea, we talked a lot about classes, understanding the concept of class and how to figure out class. That will help you a lot. It helps solve a lot of problems. Okay. So got into a lot of details about R. You really aren't going to pick these up until you work with it quite a bit. And so that's what we're going to spend a lot of time doing, is practicing this. Hopefully some of this stuff I've told you will help you understand that R code as you work with it. So let me know if you got any questions, and I'll see you later.